let me now guide you through this morning. And Stephanie's given you a really good background there to what ESERO does and all the different resources that are available to you after today's Careers Roadshow. But today is really about hearing human stories about how people working in the space sector got to where they are today. And as Stephanie said, we always like to have a theme. And the theme for this particular one for Engineers Week has to be the James Webb Space Telescope, because we've heard so much about it in the news or whatever. So so our two speakers, John and Giovanna, both of those are involved in some shape or form to the James Webb Telescope. So that's what connects us all together. So let me give you context to the James Webb telescope so that we can all kind of, some of you probably know this stuff already, so I apologize if it's too simple for you, but you always start at the beginning, I think, whenever we're talking about anything. So this is the beautiful James Webb Telescope. It really is a thing of beauty. It is a collaboration between the European Space Agency and NASA, and also the Canadian Space Agency, which is known as CSA. And this has been something we have all been waiting on for many, many years. People have been talking and working towards creating this telescope since the 1980s. It's a telescope that uses infrared and near infrared light, which I'll talk to in a second what that means, to be able to look much, much, much deeper in our universe. It's enormous. The diameter of the mirrors are 6.5 meters. And the actual mirrors themselves are made up of 18 hexagonal mirrors, and they had to be intricately folded in the launcher. I'll show you that in a second, and to fit in. And then there are these 5 layers of, I guess it's kind of like tin foil or kind of very thin foil that also folded out when the telescope was deployed. And that's a heat shield. And that's really, really important, because you have to be able to protect the telescope from the sun if they're measuring infrared technology. So the best of the minds of Europe and NASA and people in Canada put this together, and on board there are some really smart science experiments, and Ireland is also involved in that too. So the James Webb Telescope supersedes 2 other space telescopes. One was the Spitzer Space Telescope, which was also an infrared telescope, and that finished around 2020, and that gave us some great looks at some of our exoplanets. These are planets that we discovered that may be like Earth out there. The TRAPPIST one is one of the biggest ones that it would have shown us. And then there's the amazing Hubble Space Telescope, which is still working to this day, but the Hubble Space Telescope is kind of coming to its end of life. And as it's coming to the end of its life, there was a requirement to come up with something different and possibly better. But the Hubble Telescope is slightly different from the James Webb and the Spitzer in that it was using visible light. But we're very excited about what we are going to learn about our universe with the James Webb Telescope, with the technology that's on board, with the fact that it is protected so well with this heat shield, because the Spitzer telescope used liquid helium to keep itself cool, because you have to keep the telescope cool, because otherwise that's the only way it's going to be able to pick up light and heat from the stars. And the way it works this time, it's using its big heat shield to do that. And that heat shield is actually the size of a tennis court. But we want to know a little bit more about the early origins of our universe. And we want to be able to look back into the very first galaxies. And it is believed that we might actually be able to do that with the James Webb Telescope. We may also be able to understand, where do stars come from? Where do exoplanets come from? And even some of the moons and planets of our solar system. So maybe we might have a different story about where it all began. Maybe we might get a better idea of a timescale. Maybe we've been wrong in our timescale. This is what's great about science. Science is all about asking the bigger questions. And a lot of the time, our assumptions can be, well, they can be good, but they can be slightly different from where they should be. And we're hoping that we'll get clarity on that from the James Webb Telescope. And these are the instruments on board. You have the NIR spec, you have, I'm just going to minimize this quick so I can see them. And all of them are using near infrared or infrared. So we have a series of cameras on board. We have a series of spectrographs. So spectrographs will break down light into its constituent colors so that we can monitor and we can measure exactly what we're looking at. And then there are coronagraphs which block out a starlight as well, which allow us look at planets around those particular stars. So they are the main science experiments on board. And I just said already about the Hubble Space Telescope and the Spitzer. So I hope at this stage you may know about the electromagnetic spectrum. So that's about light. So the light that you can see with me right now, hello, as I'm waving at you, that's visible light, and our eyes can see visible light. But there are other forms of light around visible light. Some of them are more powerful and some of them are less powerful. So if you're heating up your sandwich or your pizza later on this evening using a microwave, that's a form of light, and it's a lower energy light to visible light. If you're tuning in onto a radio, that's lower energy light than microwave as well. And then just above microwave is infrared, and the Spitzer Space Telescope was using infrared light. The James Webb Telescope would use infrared light and near infrared light. And then beyond visible light, you've got ultraviolet, X-ray, and gamma rays, and that's where some of the light from the sun and stuff can be a bit damaging. So that's how those three telescopes work together. And you can see these are the four instruments, and these are the areas that they're going to be looking at light. So three of them are looking at near infrared, so that's just on the cusp of visible. And then you've got MIRI, which is looking at the mid-infrared. So we will have a wealth of data from that. And like Stephanie said, the James Webb Telescope, after many years of preparation, it arrived in a place called Kourou in French Guiana, and that's it there. You can see the little red arrow. That's the top of South America, and that's a launch center for ESA, and there's been many launches there on our rockets, the Ariane 5 and maybe even the Ariane 6. And this was the launch on the 25th of December. I watched it. I don't know if you guys are watching on a Christmas day. Maybe you were opening up Christmas presents, but for all of us space geeks, this was the best present of all, because it had been it can be anticipated. And I think I showed you there on the very right, because my image is in the way. Look how tightly packed the telescope was in that launcher there. So do you see it was folded up? So the mirrors were kind of folded into three parts. And so when it launched, one of the things it had to do was to open up the mirrors and then also open up the heat shield and and turn it into this tennis court shape heat shield. So anyway, as I say, it launched on the 25th of December, and this is footage. Let's turn this down, it's a bit loud, of the actual moment of release, which was a big moment for many, many scientists. It was very, very exciting watching it head away to its orbit, which was 1.5 million kilometers away. Now, every moment of an experiment in space, something can go wrong. And so it has been an amazing experience so far. Already, everything that was planned to happen has happened on time. And so the very first beginning of it was this release of the James Webb Telescope into space, and then this unfolding of its solar panels. And it has been consistently keeping up with its timeline. And we've seen some amazing things happen. So the first thing that happened was the heat shield started to unfold, and we got those 5 layers of that kind of tinfoil type thing. And that's really important because we have to face the telescope away from the sun, and to protect it from the sun, we use those heat shields. And I'll just go on because I want to go on here. And this is the timeline of everything that happened. And we're now into, so 25th of December, so we're now coming into month 3, and it is sticking to its timeline. And around about January, it finally arrived at its orbit point. It went to the Lagrange 2 point. And there's these points in orbits between different bodies where the forces kind of equalize between the two heavy bodies, and it means that the ability for an object to stay in that orbit is less than, say, if it weren't in these Lagrange orbits. It would need more energy to stay in the orbit. So the Webb telescope is in this Lagrange 2, which is the other side of Earth between the sun. And as I say, the tennis court part of the telescope is facing the sun, and we have our telescope looking out into the universe. And so it's still testing, and it will be for 6 months, but we have watched some really interesting things being reported. So you see the shape there on the left. So that's all the different mirrors focusing on the same constellation. And so I think this is a GIF. If I play it, maybe it'll work. Yeah, oh, sorry, wait, sorry, guys. Duh. If I play the GIF, you'll see that it changes. So it goes from kind of blurry to very focused. And then we had our very first selfie then in earlier that month in February. So we continue to wait, and in 6 months' time, or at the end of 6 months, we're going to start getting data. And as ESA members, as Stephanie said, we will have access to that data. So it's very exciting, and it'll open up a whole new channel of understanding of our place in space. So we thought that would be useful for you to know about before we went into hearing from our speakers. And I'm just going to get rid of that. And so let's get going, shall we? I mean, I've talked enough, and it's time to hear other people speak about far more interesting things. So